All right. Good afternoon, everyone. Welcome to Infra 105, Accelerating Application Deployments on Kubernetes with Cloud Run for Anthos. That is a bit of a mouthful. Our apologies for that. My name is Sam Ming. I'm an engineering manager at Google.
I'm Anil Devan. I'm a product manager at Google as well.
And we both work on the GCP serverless team. And so today we're going to talk with you a little bit about our plans for serverless and our plans for Cloud Run. And Cloud Run being a product we just GA'd last week, we'll tell you a little bit about what that looks like and where we're going to head forward from there.
Cool.
Okay. So first, before we get started, your feedback is greatly appreciated. We'd love for you to give us feedback about the session. For those of you who have the next UK 19 app, please go ahead and fill out the feedback there. For those of you who don't, feel free to go and grab that app and give us some feedback on the session. OK, so first, a little bit about me. This is me. I'm somebody who really likes epic things, right? I love experiencing epic things. I love seeing them. This is me standing on top of somewhere in the Swiss Alps. I'm about to cause an avalanche, which is another story in and of itself. But I love being in places where I get to experience epic things. And I also really love to go fast, right? This is one of my cars. I love to be able to experience that adrenaline rush of going really fast, whether we're talking about motorcycles or cars or snowboarding and skiing. I think that these two traits make me perfectly suited to being a software developer. And I know that's a bit of a jump, so I'll walk you through my thinking there. But particularly a software developer on cloud. And the reason why I think that is because to go fast, you really need to understand what you're working with. Right? Anyone who rides a motorcycle or races cars or does skiing, snowboarding, you really need to understand what your tools are, what the vehicles are that are helping you get there so that you don't end up as roadkill on the side of the road, right? You've got to spend enough time learning how to ride these things, learning how to drive them well, developing the skills for them, so that if you spend enough time doing these, then you can experience more time experiencing your epic for whatever definition of epic that is, right? And for me, that's really what software engineering is all about, right? It's about us going after this grand, lofty goal, us having this epic vision of something that we want to do because we think we ought to do it, and about us trying to get there as quickly as possible and having as much fun as we possibly can. That's why I really love being at Google. I think Google's mission is an incredibly epic one, right? Our mission is to categorize and organize the world's information and make it universally accessible and make it universally useful for everyone, right? And part of universal means all of you, right? We're here today to talk to you about some of the things that we're doing at Google, some of the new tools and vehicles that we're building. And we want to give you a pop under the hood to take a look at how some of these things work so that you can go fast and you can understand how these tools work and you can go fast and reach your epic for whatever definition of epic that may be. So we'll first start with an agenda slide. So today we're basically going to be talking about this concept of the evolution of infrastructure. Right, we'll start all the way at the beginning from where we've come, all the different evolutionary steps that we've taken along the way, and we'll talk about how Cloud Run, which is this product that we've just announced GA for, we believe is the next step in an evolution. We don't think it's the final step, but we think it's a next logical step in this evolution. We'll talk to you a little bit more about what it is. We'll give you a bit of a demo about how it's used, both from your simple Hello World app all the way to something that's a much larger scale production app that you can kind of go and see working. And then we'll talk to you a little bit more about where we're going with Cloud Run, right? Like I mentioned, we just GA'd the thing, and naturally that means that the questions that come up after GA are, what do we do next? What are the areas that we're going to go after next? So we'll share some of these plans with you, and at the end we'll kind of leave you with some next steps for you to be able to go ahead and play with Cloud Run yourself. For those of you who are already in our beta program, thank you for your feedback. We very much value that, and we'd love to kind of continue on this journey with you. For those of you who aren't, you'll be able to get Cloud Run yourself now that it's fully GA, and you can go and start playing with it too. So first, where we've come. We've come from this world of mainframes, right? For some of us were alive back when mainframes were working. For others, maybe we've seen some pictures of it, heard stories of it, heard anecdotes of it. But back in the mainframe days, deployment really looked like you taking your tape reel or punch card or whatever flavor of mainframe you had and going and allocating some time for yourself on the mainframe server. And when it's your turn, you stick your thing on the reel and you have it play. And then when you're done, you kind of take your reel off and off you go again, right? And that's really what deployment meant, right? There wasn't really much more sophistication than that. And that was the world that we lived in then. Fast forward a little bit and we see the introduction of data centers, right? Data centers were a revolutionary thing, especially when we coupled them with personal computers, because it meant that developers could develop their code locally on their own machines and do all of the steps that you need to build and test and all that type of thing. And then they can go and deploy the thing. Now, deployment in the data center days usually meant you had a monolithic app. And it meant that you'd say, hey, I'm going to write this thing. I'm going to, if you were sophisticated enough to have testing, great. You would go and write a bunch of tests and run a bunch of tests on it. And then you say to your ops team, hey, I'm ready for you to deploy my app. The ops team would then go and take probably an executable, right? They would go and take that thing and deploy it on the physical machines that they were in control of. They would have to deal with things like providing network access to it, figuring out ports, and with the advent of the internet, figuring out how to put it online for customers everywhere to kind of reach. And the ops team would kind of go and manage all of that stuff for you. Fast forward a little more, and we have containers. Right? We are now in a world where we've got these containerized, virtualized workloads. And this is when we start seeing a little bit more of a bleed in between dev and ops. Right? This whole DevOps thing is also a thing nowadays. But really, we're starting to see more of developers needing to learn more and more about the underlying infrastructure, whether it's for authoring with Kubernetes or whatever else. Developers need to know a little bit more about how their containers are being run, and ops teams need to know a little bit more about how developers are developing their code. And that's kind of the world that we're in now, right? Where for you to deploy your software, it means that you as dev teams, often, we hear a lot of customers tell us that they send their dev teams to things like KubeCon and to things like meetups so that they can go and share best practices, learn about best practices for how others are using Kubernetes, how others are deploying their systems. Because the reality is there's no one perfect way to do it, right? Everyone who has run a live Kubernetes instance knows that there are many ways to do the same thing, and you learning and figuring out what works best for your unique snowflake of a workload is something that most dev teams have to go and do and pay the tax for. And the last step in our evolution is cloud, right? Cloud comes in and says, hey, I'm going to help ops folks not have to manage physical machines anymore, right? Cloud comes in and says, okay, I'm going to go and provide these same containerized workloads, but on hardware that someone else is going to manage for me, so that for me to deploy, I get a lot more benefits. I get the benefits of scale. I get the benefits of being able to scale on demand, right? I no longer have to do a pre-allocation of CapEx 6 months in advance to order enough machines to kind of go and scale these things out. I can now go and on demand ask Google or Amazon or Microsoft for more machines, and they'll just kind of magically appear. But we're still in this containerized workload world, right? Even in the cloud, we're still in this containerized world where you still need to go and have that dance between dev and ops, and that's really not an ideal situation by any means. So for those of you who have been following the containers wars, right? We pretty much have realized that the wars have ended and Kubernetes is sort of your de facto winner, right? It's the last standing product that everyone basically uses now for containers. But we believe that it's not the last step in our evolution, right? For those of you who may be running Kubernetes clusters yourself, for those of you who are on the developer side, deploying software against Kubernetes, you'll know that there are still a lot of things that Kubernetes leaves to be desired, right? There are still a lot of things that we wish could be easier, that we wish we could improve upon. Now, that being said, there are many benefits of Kubernetes, right? There are a couple that I'm going to list and talk about, but there are many more than just these, right? The first, most obvious one is that Kubernetes provides us a declarative way to go and author our deployments, right? You no longer have to imperatively figure out how deployments work and what the steps are and that type of thing. You can go and just declare and state that, like, hey, here's how I want my deployment to be. Here's what I want my scale semantics to be. Here's how I want my network semantics to be. And Kubernetes will take care of that underneath the covers for you. Next is high availability, right? Kubernetes brings a lot in terms of automation for automated health checks and self-healing and self-recovery type things. Prior to this, legacy systems often required you to build your own services that would go and deal with health checks and monitoring and healing. And a lot of times, ops teams had playbooks that were literally of the form of like, hey, if this happens, then do this. If this happens, then do this. If all else fails, hit the reset button on the physical machine that you've got and hope that it kind of works, right? And so Kubernetes really helps a lot with things like that. Thirdly, Kubernetes also has a rich community of developers that are building out the technology here, right? Obviously, it being an open source project, you have a wealth of knowledge from lots of folks around the industry, folks ranging from big companies like Google to mid-sized to small-sized companies to even individual contributors. You've got a lot of folks that are actively developing the platform, and so you get a lot of latest and greatest thinking from the industry on a whole when you use Kubernetes. Moreover, you can also take Kubernetes and customize it yourself. Because it's open source, you can go and build your own CRDs and go and deploy them locally. You can keep them in-house. You can be a good community person and go and share them with the community as well. And you can kind of go and build whatever you need if you don't see it already there. And so that's a really big benefit that it brings. Lastly, you can't talk about Kubernetes without talking about autoscaling, so I'll mention autoscaling, right? Kubernetes gives you this ability to autoscale through its HPA autoscaler, horizontal pod autoscaling. Anil will talk a little bit later about Cloud Run and how we've taken on some of the load of autoscaling, how we've improved upon the Kubernetes autoscaler. But Kubernetes in itself was a big step in that direction for folks to be able to provide autoscaling out of the box. Now, we're not in an ideal world yet, right? Today, even with the advent of Kubernetes, we still have a lot of things that we need to do that we would prefer not to, right? Yes, we need to go and write code. Developers need to go and write code. But we also got to figure out how to build the containers, how to publish those containers, how to upload those to a registry, how to deploy them, what our network semantics are, what scale we need to have for our specific apps, how to set up logging and monitoring and diagnostics, all those kinds of things, right? Really, we would love to be able to just write code. But we still have a lot of things that we need to go and do. And so for all of its benefits, Kubernetes doesn't quite get us all the way there. We also have to deal with YAML files, right? This is just a sample YAML that you have to deal with. But for those of you who are running live Kubernetes instances, your YAMLs are probably more complex than this. And for those of you who don't know, YAML files are things that developers have to go and write. And so many times, companies will go and send their devs out to go get training on Kubernetes so that they know how to write these YAMLs and they know how to interact with their ops folks as they kind of go and do this. And this by no means is easy. This by no means is perfect. For anyone who's tried to hire a large number of DevOpsy type folks, they're hard to find, right? Most developers like to just write code and they don't want to have to deal with infrastructure. And so we're not really in an ideal scenario by any means. The reality is that developers love things like velocity and things like reproducibility. Devs love to be able to write lots and lots of code, and they don't want to have to deal with infrastructure. They don't want to have to deal with learning another system just to get their code deployed and just to get their code running, right? If we're honest, devs are picky, right? We're picky and we are lazy. We like to go and automate things that we don't like, and we like to spend our time doing the things that we do. And that means that we like to go and automate things like infrastructure because we don't like to do infrastructure. And so the question I'll ask is, what if things could be easier? And that question is something that we love asking at Google. Google is a company that thrives on asking that question. What if we can make things easier? What if we can make things easier for us as developers? What if we can make things easier for you as our customers? And for this particular question, our answer is Cloud Run. And so first, let me show you Cloud Run in action, and then I'll go ahead and talk a little more about what you're seeing. First, I need to get my machine to wake up. OK, so great, you can all see. So here we have our Cloud Run console. Very vanilla console, nothing to display right now because we don't have any services. So I'm going to go ahead and click Create Service here. And what I'll do is I'm going to select a container. Now, I've gone and pre-built a container. This is just a Hello World container. All this does is it prints out Hello World. It checks a command line variable, an environment variable, and it will go and print that out so you can kind of see what environment we're coming from. So I'll go ahead and set that environment variable here. And I called it env. So we're just going to say we're coming from GKE. I'm going to go ahead and create my service. And this thing will come up pretty quickly. I'm also going to go to my command line here, and I'm going to get my public IP, my load balancer IP for the service. So I'm going to go and grab this thing, and I'm going to go to it. And we'll see our Hello World app deployed on GKE. Right? OK, let's go back to slides for a second. So what is Cloud Run? And what does it do for you, right? How did all of that stuff just work? Well, in order to answer that question, I'm going to give you a little bit of context first. For those of you who've been paying attention to this conference, we've talked a lot about this thing called Anthos. The way that I like to summarize Anthos is it's really just a bold idea that we can go and take deployments and have you target Anthos as a deployment system and hide everything underneath the covers for you, right? Whether or not your underlying fabric is running on GKE, on GCP, maybe you're running in AWS, maybe you're running some things on-prem, maybe you're running on Azure. Anthos is this dream that says, hey, we can go and abstract away all of that so that you as developers can, again, have that level of abstraction with your ops team such that you only care about writing code, right? And we'll take care of the rest. We'll take care of deploying that on-prem for you. We'll take care of deploying that on GKE for you and that type of thing. And so Cloud Run is something that sits on top of Anthos. Right? As many of you know, Google is very, very well known for building a lot of building blocks. Right? Kubernetes is an example of this. We build a lot of these building blocks that are very, very powerful. They're very configurable. They give you a lot of options for you to go and use them however you want so that you can go and build your solutions for the problems that you're trying to solve. But as many of you also know, customers are constantly asking us to be a little more opinionated because these building blocks are really not, right? They're not meant to be opinionated. They're meant to be as flexible as possible. But we've heard from a lot of customers like yourselves that they would like Google to be a little bit more opinionated. They'd like some best practices. They'd like some better defaults out of the box for you, right? And so really Cloud Run is our attempt at that, right? It's our attempt at saying, look, we think that this is how the separation between dev and ops ought to be. And these are the things that we think devs want to care about, and these are the things that we think ops folks want to care about. And so we're going to go and present a solution that allows you to go and do that. And so the way that you can think of Cloud Run is it's really a layer that sits on top of Kubernetes that goes and simplifies all of that stuff for your development teams, but still gives you the full flexibility and power of Kubernetes underneath the cover so that your ops teams can continue to manage their ops the way that they want to. And like I mentioned, because Cloud Run sits on top of Anthos, and Anthos wants to deploy against GKE and on-prem and AWS and wherever else that Anthos is built on, Cloud Run gets a lot of those benefits as well. So next I'm going to show you that same container now deployed against multiple clusters. So what I'm going to do first is I'm going to go navigate to my GKE console. And what I've done ahead of time is I've gone and connected 2 additional Cloud Run clusters here. I've connected a AWS cluster that's running, and I've connected an on-prem cluster that's running too. And so what we'll be able to go and do is we'll go to our Cloud Run dashboard. And we're going to go through those same steps. We're going to go and create that same service. Now, I promise you, no one underneath the covers has changed anything, right? Anil's laptop is here, so he's not rigging with this thing for me. He's not rebuilding anything for me. We're just going to go use that same container here. And we're going to go and deploy it to the various clusters that I've got set up. So let's go and deploy one on-prem. So this is my on-prem cluster that I've got here. And again, I'm going to go and do that same thing with our environment variables so that you can see that we're deploying from on-prem. I'm going to go ahead and create this service. And then I'm going to, as that's creating, I'm going to go ahead and create an AWS service as well. Right, I'm going to go and select that same container. Now, underneath the covers, what we've got running here for the AWS one in particular is we've got an alpha version of GKE for Anthos running on top of AWS. This is something that we're going to release later on in 2020, but right now we've got some alpha bits that we're running off of here. And again, I'm going to go and do that same thing where I set my environment variable, and I say that I'm running in AWS. OK, now I'm going to go back to my Cloud Run dashboard. And we'll see that all 3 of these things are up and running. So first things first, I'm going to change my Kubernetes config so that I'm now using my on-prem context. And then I'm going to go ahead and get the external IP. I just aliased a couple of commands so I don't have to type them all out. This is the IP for my on-prem cluster, which we'll go to. And we'll see Hello World is deployed on-prem. Now for AWS, because it's an AWS load balancer, there's a couple of separate commands, so I'm going to go ahead and grab that as well. Now you can see this actually is a load balancer from AWS. I'm going to go ahead and visit that, and we'll see Hello World being deployed on AWS. And so hopefully you can see that it's just that simple, right? We've gone and done a lot of the work to make it so that you can very easily go from container to running anywhere that Anthos is running without any changes, right? I didn't rebuild. I didn't change any YAML configs. I didn't do any of that stuff. I just went and deployed my service to the different targets that Anthos targets for us. So Anil's going to come up now and tell you a little bit more about Cloud Run and how you can accelerate your deployments moving forward.
Cool. Thanks, Sam. So you got a sneak peek at what Cloud Run does, but you might be wondering what exactly is Cloud Run, and I'm happy to tell you more about it. put simply, well, let's maybe take a step back. How many of you are running Kubernetes clusters today? Just a quick show of hands. Awesome. How many of you are platform teams supporting the rest of your organization with those Kubernetes clusters? Okay, so quite a few folks. So the way we think about Cloud Run for Anthos is it's Kubernetes the easy way. As Sam pointed out, one of the challenges we see today is while we want to have separation between dev and ops, when it comes to containers, especially deployed in Kubernetes, it's simply not possible. And this is one of the things that Cloud Run is attempting to solve. A couple of points on how we've kind of architected Cloud Run for Anthos. It is a set of components that live inside your cluster. So it's not a parallel stack. It doesn't have its own node pool. You don't need to worry about provisioning separate resources for it. The way I like to think about it is it's a set of components that helps you target your Kubernetes clusters and does so in a way that incorporates Kubernetes best practices, as Sam mentioned, and creates a better bridge between ops and dev. The Kubernetes cluster itself, when it's running Cloud Run for Anthos, you can also run your existing pods and deployments the same way you do. So it's not like a binary choice. The two coexist quite nicely. And ultimately, under the hood, Cloud Run is programming a lot of the control systems inside Kubernetes and Istio that you would have had to do yourself, but it's just automating it for you. So ultimately, Cloud Run does three core things. One is it simplifies the Kubernetes experience. But two, as we think about what do developers need when running apps, and what do ops people need when they're managing those deployments of those apps, we've added specific capabilities that don't exist today in Kubernetes for Cloud Run applications. And I'm going to get more in detail in just a bit. And last but not least, we simplify the experience around deploying and describing your application to the Kubernetes cluster. And that gives you, for the first time, I think, a higher level view of your application. I'm going to show you in a demo kind of some of the cool things you can do once you have that higher level abstraction. So first, how do we simplify the application deployment and management experience with Kubernetes? So Sam earlier showed you a bunch of YAML that you would have to write. In fact, 2 files of YAML, service and deployment, in Kubernetes when you're trying to deploy a service. With Cloud Run, that same YAML gets generated behind the scenes for you in a very simple command. So this is our gcloud command line, the standard command line you use in GCP. And you can see you just do gcloud run deploy. And basically 2 things here. One is the name of the service, and the other is the container image. And what this does behind the scenes is it goes and fetches that image, creates an immutable snapshot of that image along with its configuration. So in Sam's demo, you saw he was setting some environment variables. Those are snapshotted together. And if this sounds familiar, it's because we're building on the Kubernetes philosophy of infrastructure as code and declarative configuration. So we snapshot that together, and then we go out into the cluster, and we actually set up those pods, hook in the ingress. We figure out whether you want to expose this service publicly to the internet or internal within the cluster. And we manage it all up for you. We do health checking. We make sure that the deployment is both deployed and actually active. So it's the container image is up and running and is healthy. And finally, we come back with a full URL with your service live up and running. So if you've done Kubernetes deployments yourself, you realize there's quite a few steps that we just kind of glossed over here because Cloud Run has taken care of it for you. Of course, there's a simplified command line, but you also have the full flexibility of YAML. And this time, hopefully it's a much simpler YAML than what you saw before. This is a Cloud Run-based YAML. And I've highlighted in green kind of the key portions that you need to think about. And this YAML I generated from that previous command. So I ran that command, and then I looked at the YAML, and I saw this is what was created. And you can see it's pretty straightforward, and I think it's quite intelligible. So we see the name of the service. We see the Kubernetes namespace into which I've deployed this service. In this case, it's just the default. You can see the containers that comprise this service. In this case, I have 1 container, and it's got its path. I've also set up some resource limits to say it needs 1 CPU and at most 128 megs of RAM. And I've got some timeouts, et cetera. So a much more simplified document. And hopefully what you're taking away from this is it's very intelligible even for a developer or an operator of the application. So next, as Sam showed you, Cloud Run is integrated right directly into the Google Cloud Console. And so from a Cloud Run perspective, that means we're able to do some really interesting things, like give you full operational visibility with Stackdriver for any of the services you've deployed with Cloud Run for Anthos. So in this case, I'm showing metrics. I'll also show you logs later on. And these come built in out of the box, no configuration needed. You get these just by default. The next is a set of new capabilities, as I mentioned. Things that you technically could do with Kubernetes, but you'd have to build them yourself. Things that Kubernetes doesn't do out of the box for you. So the first is auto-scaling. Well, Kubernetes does support auto-scaling. As Sam mentioned, there's something called a horizontal pod autoscaler. But the way autoscaling works with the HPA is it's looking at memory and CPU as its inputs. And what we find with lots of customers is that while this works, it's actually very slow to respond to peak traffic. What Cloud Run does is it has a request-based autoscaler. And what that means is it can actually look ahead and see how many incoming requests are happening. And it doesn't really worry about CPU and memory. It looks and says how many pods are able to service these number of requests simultaneously. And if it finds that things are getting backed up, it will go ahead and talk to Kubernetes and spin up more pods on your behalf and get ahead of that traffic. Again, things that are typically challenging today with an HPA. And so here's an example of that. A couple things here. So one is on the vertical axis, we have the number of pods that are deployed for this service. And again, with Cloud Run, you don't have to worry about the pods. This is what's happening on the cluster when you deploy your service. So we've deployed a service, and we started throwing some traffic at it. And each Cloud Run service is able to handle or service multiple concurrent requests, which means you're actually a lot more efficient. And at some point, based on the load, you need to scale up. And that's what we see happening here at the kind of the 5-minute, 31-second mark, is Cloud Run is detecting that there's a lot more incoming load, and we're going to need a lot more pods. So it does. It goes and tells Kubernetes, hey, spin up more pods. And then what it does is actually looks at the pattern of traffic and tries to get ahead of it. And so that's what you're seeing here. So you're in an ideal auto-scaling situation, you would have this one-to-one correlation with very few windows that are separated. And you can see right here, there are very few windows that are separate, meaning that you got a tight envelope that's fitting the curve of your load, and you're not over-provisioned or too under-provisioned. So again, these are some of the advantages you get with using a request-based autoscaler. And of course, it works in the reverse direction. Once that peak traffic dies off, we can see how quickly requests are falling off, and we're able to aggressively kill the pods and free up those resources on your clusters. The next big benefit is the ability to scale to zero. So you could do this in Kubernetes yourself. You'd have to write a lot of code and deal with a bunch of YAML. It's not something you get out of the box. And you'd have to do that per pod and per deployment. With Cloud Run, this comes out of the box. So your services by default scale to 0. You can, of course, tweak that. You can set a min scale to a certain number, so if you always want a certain number of pods active on your cluster. And so why is this important? What we hear from customers is they want to have better resource utilization for both their cloud and on-prem clusters. And so by scaling things to 0, you're able to better amortize or average out workloads that might be diurnal. Maybe you have some jobs run in the evening to maybe summarize some records or parse through a bunch of data, whereas during the daytime, you're actually serving live HTTP traffic for a website. You can actually bring those workloads onto the same cluster, deploy them with Cloud Run, and let Cloud Run manage the autoscaling. And so the fact that you're going to 0 means you can deploy multiple services on this cluster without actually leaving a footprint behind. And of course, when a request comes in, when our first request comes in, we will hold on to that request, work with Kubernetes, spin up the pod, and then connect the ingress, and then off you go. And similarly, in the other direction, when there's very few requests or no requests, we will spin that down back to 0. So achieving better resource utilization across all of the Anthos clusters you have, whether they're in cloud or even on-prem, where it's a little bit more difficult to start racking and unracking machines, this makes it possible. The next is load balancing. So okay, Kubernetes does have load balancing, but getting into the details, it's based on connections. And the Cloud Run load balancer is actually based on what you more classically think about in terms of QPS, which is request. And so these types of differences help us create new capabilities, like the ability to traffic split. So you can say, hey, here's a version of my Cloud Run service, and here's a new deployment of it. And I want to incrementally roll out traffic onto it. Because we can do things by request, you can actually have percentages. And I'll show you in a demo in just a bit how that works in practice. And last but not least, because we have this higher level abstraction, you finally can reason about your application in different ways and do these types of interesting scenarios like traffic splits. And so here I'm showing the Cloud Run object model of an application. There's a higher level concept of a service, which is composed of two things: a route, which controls network ingress into your service, and a configuration. And a configuration is that snapshot of what we call, it's a snapshot of revisions. And so each revision is composed of a container and any of the surrounding configuration. And so you can imagine with a CICD pipeline, every check-in, every commit that's green goes and you deploy a new revision of your service. But typically what happens is a new revision would get pushed out and you would have traffic coming to it, which is not what you want. You instead want the service to be alive so your QA team can do some final validation, and once you're satisfied with it, maybe start flipping traffic over to it. And that's what Cloud Run enables. So again, we're trying to encode some of the best practices around application deployments with Kubernetes and make those first class. Everything I've just spoken about so far is about Cloud Run, but Cloud Run is based on the open source Knative project. It's a really, really robust community. It's been around for almost 2 years now, and we have major vendors throughout the industry constantly adding contributions. And what this means for you is when you're using products like Cloud Run, is you're getting not just Google best practices, but you're getting industry-wide best practices of Kubernetes deployments. And we'll show you kind of a little bit more of like where we're headed in the future as well. So great, so I've told you a lot about Cloud Run for Anthos and what it can do. You might be wondering, well, what kind of workloads are eligible to run this way? Well, so first let's talk about the containers. Well, the beauty of containers in this model is you can have any language, any binaries, any libraries or dependencies, and Google has a rich ecosystem of base images. But really, any industry standard Docker image will work with Cloud Run for Anthos. That's the first takeaway. The next is we have a container runtime contract. So great, you've got a Docker-based image, but what is the image actually doing underneath? So there's, I'd say, 2 core requirements for your workload to be eligible to be run with Cloud Run. The first is that it should serve HTTP traffic. All of the load balancing, all of the kind of features that we have sort of assume HTTP. There is gRPC support coming soon. So we do have to have our eyes on other protocols, but typically today you'd work with HTTP. And then the next big thing is you want to make sure that your application or your workload is stateless. If you're bundling a Postgres database next to your application container, it's not going to be a good fit. And the reason for that is because we're aggressively scaling up and scaling down your workload. And so if you have state that's inside the application that it depends on, you're not going to be able to persist that. This is usually not a problem if people are already using Kubernetes. They probably have a set of pods that are already running their database, or maybe an external cloud service doing that for them. But in summary, I think those are the 2 big requirements: an HTTP serving workload that's stateless. So great, what can you do now? Let me show you a couple of quick demos that highlight some of the features we just spoke about. So great, if we can flip to the demo. Oh, cool. See my screen? Great. So cool. What I have here is one end of the scale. What I'm going to show you is a very, very simple container with a very, very simple application. And arguably, it's not even an application, it's just a function, very much like a Google Cloud function. And so it's using Node.js, and all it's doing is it's outputting a simple snippet of HTML. And it's saying, hello, London. And what's nice about Cloud Run is it can run any container. And your containers, of course, can be very complex, but they can also be very simple. And so in this case, what I'm doing is I have a little snippet of code that's more like a function, but I'm able to turn this into a container. And I'm able to do that because at Google, we've created something called a functions framework. And so we support a variety of languages. And what this allows me to do is very easily focus on writing a function, and then I add in this one dependency. In this case, I'm using Node.js. So I've added a dependency to this Google Cloud Functions framework. And what that's going to do is it's going to wire up the HTTP serving into this particular method. So it kind of takes care of all of that for me. So as a developer, I don't need to worry about it. So great. So I come here, I have my application code. I want to build a container. So I use gcloud submit, which uses Google Cloud build, creates a container, and puts it into the Google Container Registry. So I did that a little before the talk to save some time. And let's see what it looks like to actually deploy this, this service. Let's create a new service. And let's go find that container. And I put it in the Hello London repo. And this is the plain version, which is the V1 of my application. And I'm going to go ahead and deploy it on this cluster I have and expose it on the public internet. So great. So what's happening underneath is all those steps I mentioned before. We're snapshotting the container. We're making an immutable copy called a revision, which is what you see in this list here. And we're programming the Istio route so that network ingress can flow in, and off we go. So things are green. And you can see here that it's allocated 1 CPU with a maximum of 256 megs of RAM. There's a concurrency factor of 80 because it's a stateless workload. It can scale up quite nicely. And I've got some timeouts. And again, there's also a backing YAML. Again, I didn't deploy it this way, but here's the backing YAML in case you're interested in seeing that. But I'll focus your attention here. So I've deployed the service, and now I have a live HTTPS or HTTP endpoint. So I'm going to go ahead and open that in a new tab. And we see it says Hello London. So pretty straightforward. So I've gone from a simple Node.js function, and I've deployed it on Cloud Run on this cluster, and off I go. So let's say my product manager comes up to me and says, hey, you know, we have a PZR request. We need to make this a little bit more fancy. I say, sure, no problem. I took a note of that in a meeting earlier, hoping that he wouldn't come back to me and ask me for that. But he has. So we decided that we're going to make this fancy by adding a little bit of emoji, because everyone loves a little bit of emoji. I'm not sure why it's happening here. I'm going to paste this here, and I'm going to go ahead and save this, and I can kick off another build, which I've done before. And let's go deploy that service. So now, this time, I've already deployed a service, so I don't want to deploy a new one. I just want to deploy a new revision to the existing service. So let's go ahead and do that. And so I'll select in that same Google Container Registry. I have my fancy label attached to this. So this is the fancier version of that application. And I'm going to go ahead and deploy it. And you can see this check mark at the bottom. It says, when I deploy this, put 100% of traffic on it. And I can easily uncheck it. And this would be a great case for testing your application. In this case, I'm OK with 100%. And that should deploy in just a matter of seconds. And you'll see that 100% of traffic is now flowing to the second revision. So let's go back to our tab and refresh. And we see that we now have our fancy version of our application. But let's say my manager, she comes in and she says, hold your horses. We're not sure if we want to be fancy or plain, and we want to do a little bit of an A/B test. Can you go make that happen? I say, sure, not a problem. What Cloud Run can do is this traffic splitting. So let's go ahead and show you what that looks like. I'm going to go ahead and choose the current revision. I'm going to say manage traffic. And what I can do here is I can choose amongst all the revisions of this service, and I can actually split the load. In this case, I'll do 50-50. And this is where that Cloud Run object model comes in handy. What's happening here is not a new deployment, but we're just tweaking the routes. So we're not deploying new application code or things on the cluster. We're just simply tweaking the network ingress. And that's a handy trick, because what that means is that now we can do A/B testing just out of the box with these containers and revisions. So here, I'm just refreshing the app, so half the time you're going to see the plain, half the time you'll see the fancy version. And so you can see I did this all without deploying a new revision, simply from the console. Really, really, really straightforward. So great, that's a pretty simple application. I went from a function to a container, and that's one end of the spectrum. But Cloud Run is also very capable and a good fit for large-scale microservices. So I have an example here of I think it's like a 10 or 12 microservice application. It's a typical e-commerce application with a cart service, a checkout service, an ad service, a currency service, and all these things. And what I've done is I've gone ahead and I've deployed this to the cluster using Cloud Run. I'm going to show you what that looks like. And so here I have all these services listed here. And let's jump into one of these. So the front end is the one that's publicly exposed onto the internet. And you can see that here, where we have connectivity. So most of these services are internal, but you can see my front-end service is indeed exposed externally. So I'm going to go ahead and open that. And prior to this talk, I did a little bit of load generation. So you can see, there are some pods that spun up there, and you can see the load. And here's where I'll show you some of the operational visibility you get out of the box. And so I have one revision. You can see all of the environment variables I'd set up to locate the other microservices. I've got full logs for my application. These are both the request logs and standard out and standard error. They're all put in one place. And I can filter based on any of the parameters I need. And of course, I always get access to that backing YAML. And so just to kind of prove that this isn't smoke and mirrors, we actually have this up and running. Let me go ahead and go to the front-end service and open this in a new tab. There we go. And so I have this online boutique store, and it's a fully functioning e-commerce site. I can go ahead and add things to my shopping cart and check out. I'm not going to go ahead and do that, but just want to give you a flavor for the range of applications that can be deployed with Cloud Run for Anthos. Let's flip back to the slides. So great. So that's what you can do now. And you're probably wondering, OK, great. I like some of these benefits. How do I use this inside my existing Kubernetes clusters or in my environment? So I'll talk to you a little bit about that. So first is CICD. The fact that Cloud Run deployments are captured as YAML makes it very, very straightforward to stick it into your CI/CD systems to have repeatable deployments. And so you can see simple YAML, continuous delivery, not a problem. Whether it's tools like Spinnaker or even commercial tools like Circle CI, they all just work. The next is we find lots of customers using private clusters. This is where the nodes in the Kubernetes cluster are actually on private IP addresses or on a VPC. Cloud Run works just fine here, not a problem. So these services would be exposed into your VPC perimeter. The next is we see multi-tenant Kubernetes users, large 5,000 node cluster shared across a variety of teams. And a classic pattern in Kubernetes is to assign a namespace, which is a unit of isolation for tenants. And because Cloud Run services are deployed into namespaces, what that means is you get all of the benefits of the role-based access control, security, policy, any of those configurations that you've already set up or invested in for your namespaces. They're going to just work with these Cloud Run deployments. So you're not losing those by going for this, for this approach. And we have a growing ecosystem of serverless partners. And so you're probably using many of the names you see up here, whether it's a Palo Alto Networks firewall, or JFrog for Artifactory, or any of these great services. We have partnerships with each of these, and we're growing this list on a monthly basis. They each have white papers and blog posts that show you exactly how to use their solutions with Cloud Run for Anthos. And so again, in a commercial context, you're likely going to be using many of these, and so you can get up and running quite fast. Cloud Run is GA, so we're really proud of that. We've been working on it for over 18 months now, I would say. So we're quite proud of this milestone that we announced this week and last week. And Cloud Run is available both for Cloud GKE as well as all of the environments that Anthos supports, including on-premises, and as Sam showed you, coming soon to AWS. And so it's GA today. We'd love for you to take advantage of it, but we'll also give you a sneak peek into where we're headed next. So I want to invite Sam back up on stage to tell us a little bit more about that.
All right, thanks, Anil.
Yep.
So where are we going next? As Anil mentioned, we've just GA'd this thing, and naturally the next question becomes, what are we going to go and target next? What are the features that you all will be able to see coming up next, and how do you give feedback into those features? So the first set of scenarios we're going after is the operator. Many of you in this room may resonate with this scenario, but for us, an operator is anyone and everyone who is involved in all the way from setup, configuring these infrastructure deployments, running them, managing them, even platform teams who build platforms as a service for your development teams to go and run on that have specific to your application type configurations that will, you'll be able to hide some of that for your developers and streamline your process. We think of anyone in that realm as operators. And so we're going to be building a lot of tools that will enable you to build and configure these deployments really easily. We're going to make it so that you can set up Cloud Run instances, whether it's on-prem or on AWS or on GKE or on Azure. We're going to make it so that your setup and config experience is very easy. We're also going to make it so that your live monitoring becomes really easy as well. So as a very simple example, imagine you're a retailer and as many of you in this room may be, and you know that your traffic patterns happen to be that, for the most part, the majority of your workload looks kind of like this, and then whether it's during the holidays or a special event or a sporting event type of thing, you have a big spike in traffic. And what happens today a lot of the times is that companies will go and pre-provision hardware so that they can go and handle that spike in traffic at max load. And what that will typically mean is that for the majority of your year, your hardware utilization is going to be very, very low. We've seen from the order of like 1 to 5% hardware utilization for companies spread across the year just so that they can go and manage this influx of traffic. Well, with Cloud Run, especially with Cloud Run on Anthos, the nice thing is that you can go and say, look, I'm going to keep my deployments on-prem pretty bare, right? I'm going to make sure that I have enough capacity for my regular workloads, and I'm going to go and load balance the rest into the cloud if and when those spikes kind of happen. As an operator, you need the ability to go and do that. You need the ability to go and orchestrate what that looks like. And so we're going to be building these types of tools for folks that are going and running these deployments. But let's not forget developers. As developers, the reality is no one is coming to us and saying, hey, Google, I have a container and I need some help deploying it. Right? What they're doing is they're coming to us and saying, hey, I have a problem that I want to go and solve. I have some code that I want to get deployed. I have a problem space for my customer. I need to go and build a solution for them. And I want a stack that takes me from start to finish, from my problem space all the way to my solution. And so one of the things that we recognize is that means that we can't just focus on operations. We can't just focus on the infrastructure. We can't just focus on your IT ops experience, but we need to go all the way up the stack to meet your developers where they're at as well. The reality is that modern development isn't us devs going into a room and coding with our IDE, starting from scratch with our IDE and coding till our eyeballs go dry, right? And then deploying your app and calling it a day. The reality is the majority of modern development is you starting with pieces. You starting saying, look, I'm going to take some pieces from here and some pieces from there. I'm going to take all these services and I'm going to glue them all together, and then I'm going to build my business logic on top of that, right? The reality is devs love writing code. They hate gluing things together. And so we're going to go and make it easy for you to do both. We're going to go and partner with your favorite IDEs to give you a great developer experience, whether we're talking about editing, debugging, local debugging, all those types of things. But we're also going to go and help you glue things together really easily. Like Anil already mentioned, we've got a lot of partners that we're lined up with to build some custom integrations for. But we're also going to go and tie together Google and non-Google pieces, right? We're going to make it easy for you to connect things like spanner databases and GCS, and if you're building things with G Suite, we're going to make that super easy for you to go and do. We're also going to work with your third-party pieces. We're also going to work with partners to give you great integrations there as well, too. Our goal is that Cloud Run may be your choice because of an operations perspective, because of an infrastructure perspective, but we want to make sure that it's a great choice for your company, regardless of whether we're talking to the ops folks or the developer folks. And so let me just quickly recap what we talked about today, right? So we started off by saying we're going to talk about the evolution of infrastructure. Hopefully you've seen that where we've come and the evolutionary steps we've made along the way have really led us to where we are now. And hopefully you got to see some of the features of Cloud Run and can see how we think it's the next step in the evolution that we are in today. We don't necessarily think it's the final step, but we do think that it is a meaningful next step in the evolution today. And so hopefully you can see where we want to go next and can get excited about that as excited as we are. And if you want to, here are some next steps for things that you can go and try. I want to thank you all for being here. I know it's the last time slot of the last day, but thank you so much for your time. And Anil and I will be up here for any questions if you have any after the talk. Thanks.